While I was at Ruby DCamp a few weeks ago, Sandy Metz asked me to write a version of Conway's Game of Life in a semi-functional stateless style. I decided to represent the concept of a live cell and a dead cell as two different kinds of object. The game grid would then be represented by a simple array of arrays, populated by live cells and dead cells. I was all set to write a class for each, when it occurred to me, since this is a stateless implementation, there was no real need to have individual live cell objects for every live cell on the board, and the same goes for dead cells. Without any state, every instance would be exactly the same, and since the objects didn't have any need for initialization, why even bother with classes? Instead, I created the objects as singleton instances of the object class. I assigned the instances to constants so they would be available anywhere in the program. Then I used Ruby's singleton class syntax to add methods to each one. Each object needed two methods, a toAs method to represent the cell on an ASCII grid, and a method to determine what the next generation of its grid square would contain, either a live cell or a dead cell. Then I could just populate my grid with the same live cell and dead cell objects over and over again. This worked quite well, but I didn't like the fact that the singleton objects had to be created in 2 steps. So I decided to see if I could create the object, assign it to a constant, and define methods on it, all in a single statement. To accomplish this feat, I took advantage of the fact that Ruby allows variables and constants to be assigned inside parenthesized subexpressions of a statement. A class plays 2 roles in an OO program. 1, it provides a container for behavior that's shared by many objects. And 2, it acts as an object factory, manufacturing new instances and ensuring they are initialized correctly. When we have an object which does not need to share behavior with any other objects, and which requires no initialization, that renders both roles of a class superfluous. In cases like this, it can make more sense to just use a one-off singleton object. Another way to accomplish this is to use a module as our singleton object, and only define class-level methods on the module. Let's update the example to use this approach instead. This is a perfectly legitimate way to implement singleton objects. Personally, I feel that using a singleton instance of object is a little more intention revealing, since modules are usually used as namespaces and as means of sharing behavior. But I don't feel that strongly about it. The main thing I hope to convey in this episode is simply that sometimes a singleton object is all we need, and when that's all we need, that's all we should use. I should make one last point here. I'm talking about singleton objects, not the singleton pattern. The singleton pattern describes a way to control the construction of a particular class, such that only one instance is ever constructed. Singletons following this pattern have often been used to manage a great deal of centralized state, a situation that can lead to a number of problems, including thread contention and proliferation of dependencies. The singleton objects we've defined here are stateless and more akin to the immutable singletons that Ruby provides, like true, false, and nil. As such, they are somewhat less prone to abuse. Okay, enough for today. Happy hacking!
Hi there, I'm Avdi. I'm the creator of Graceful.dev. If you enjoyed the video you just watched, I want to tell you there are a lot more where that came from. So if you're ready for more, come check us out at Graceful.dev to get access to our complete and constantly growing catalog of courses. I hope to see you there.